We now return to World's Strongest 3 on Modern Marvels. In the depths of this open-pit coal mine in Wyoming's Powder River Basin, everything is big, really big, including this Latorno L2350. It can excavate and load 100,000 tons of material in a day's work. To get the job done, it relies on the world's strongest tires.
As each successive technology has increased, both in tire technology and equipment technology, the sizes continue to get bigger and bigger and bigger. It's all about productivity, moving more material faster, more efficiently to be able to complete the projects, bring them to fruition sooner.
At the Bridgestone Firestone off-road tire plant in Bloomington, Normal, Illinois, the world's strongest tire is born amidst an ocean of rubber.
The three tires that you're looking at right here represent the output of our sister plants. These are the tires that most of the consumers are familiar with: a sports car tire, a passenger tire, and a light pickup truck tire. What I have here represents the output of the Bloomington Normal plant from 4 foot to 6 foot to 8 foot to 10 foot, all the way up to the 13-foot world's strongest tire.
The Bridgestone 70/70/57 Super Rock Grip Deep Tread tire weighs about the same as a school bus, nearly 15,000 pounds, with a load carrying capacity of 300,000 pounds. Bridgestone Firestone constructs the 70/70 in layers or plies of rubberized nylon cords. The nylon provides strength to the rubber, and the rubber insulates the nylon cords to prevent them from rubbing against each other. One finished tire contains 48 plies, more than enough surface area to cover an Olympic-sized swimming pool. Each tire requires 40 workers and 88 hours of painstaking labor, and a mountain of raw rubber. The first step is to join the nylon cords to form the rubber plies.
Each of these plies is a rubberized nylon cord, very much like I have in my hand right here. There's up to 21 of these cords in every inch of that ply. The plies are up to 17 foot wide.
A team of skilled tire builders then begins layering the 48 plies on a massive hub.
There's a combination of high technology that goes into building the tire and a fascinating amount of hand craftsmanship that has to happen in order to get the tires produced.
A passenger tire, when we build it, takes about 6 minutes. It takes these 4 men 14 hours to put together one tire.
Every 12th ply, the workers insert a bead. The bead is like a heavy steel hula hoop. Its high tensile strength keeps the tire mounted on the wheel. One tire requires 8 beads.
What I have in front of me here is one complete set of beads for a 70/70/57. These 8 beads, each of them weighing 80 pounds, combined total of 640 pounds of steel here, is comprised of 20 individual strands of wire insulated with a special rubber compound to keep the wires from abrading against each other. These 20 strands have been wrapped around a 57-inch diameter wheel 44 times. The amount of wire, if I laid it out end to end, would stretch out nearly 20 miles in total length.
Once the beads and all 48 plies are in place, a stitching machine removes the trapped air and seals up the sections. Workers then place the hulking rubber roll on a hydraulic press for shaping. The press applies pressure on the outside, while a huge rubber bladder inflates on the inside. And a tire begins to take shape.
We're inflating that bladder with carbon dioxide at about 25 pounds of pressure, while at the same time we're compressing the beads together. So we're taking the tire from essentially a barrel shape down into a tire shape.
But this tire has only just begun to cook. Workers next place it into a large mold. A 105-ton domed oven filled with hot steam covers the mold. Scalding water fills the rubber bladder inside the tire.
We're heating the tire from the inside out, the outside in simultaneously, and rubber's not a very good conductor of heat, so it takes about 22 hours to get this tire up to the temperatures on the very deepest inside portions. So now is when the chemical reaction takes place.
The chemical reaction is called vulcanization. Heat causes the rubber molecules to physically link with sulfur molecules, producing a more stable and durable material. The mold's shape forms the tire's tread pattern.
At this stage of the process, we're nearly finished with the tire. This is final inspection. What the worker here is going to do is he's going to examine every single square inch of this tire, all around the outside and all around the inside. If he finds a little molding anomaly, he'll address it and take care of it.
Before the tire hits the dirt, designers have to be certain it can support massive loads over months of service. Each tire is structurally over-designed to ensure that a rapid air pressure loss, or the world's biggest blowout, can never happen.
We're going to put 100 pounds of pressure in the tire, which is its normal operating conditions, and then we're going to load the tire against this 15-foot diameter test drum at 250,000 pounds of pressure. We're going to measure the deflection, we're going to measure the temperature in the tire, and all the parameters that the tire has to live up to deliver the expectations that our customers want.
There's one and only one vehicle using the 7070 off-road tire. Today, it's pulling a double shift, removing rock and soil in a Wyoming coal mine. The Latorno L2350 is the world's strongest wheeled loader. It's no job for a first-time driver.
Starting to come into the bank, hoisting, curling the bucket as I go through. Usually it takes about 4 or 5 buckets to fill the truck.
That's about 400 tons of dirt to fill the biggest haul truck. Since the tires are so critical to productivity, they need protection.
On around here, we have a set of chains installed on these tires. The purpose of these chains is to avoid damage to these tires. These chains weigh approximately 5 to 6 tons. They run only on the front of the loader tires.
They keep it so you can't get rocks or anything in to cut any of the tread, because once the tread gets cut, you get a little moisture in it, it separates, and then the tire is no longer any use to us.
In the Powder River coal mines, a set of 4 hard-working 7070 tires will last about 6 months. They'll do for now, until the day that new compounds or construction techniques crown the next world's strongest tire and its companion loader. A strong tire may be the key to mining on a massive scale. But for a small number of daredevils, it's not the tires, but the frame that really matters when trying to survive a jump on the world's strongest bike. One 7070 off-road tire inflated to 120 pounds per square inch has enough potential energy to blast a 200-pound man nearly 10,000 feet in the air. World's Strongest 3 will return on Modern Marvels.